All right, so the last one was the hard one, so let's do an easy one. So here I've got this system where I've got this weight of 200 grams, and I'm saying this has an oscillation amplitude of 5 centimeters and an oscillation period of 2 seconds. Okay, so what's going to happen is this guy's going up and down, right? Like we said, it's going in this sort of sine wave. And it's got this position function as it's going up and down as x. So in this case, this is a position function where we lifted this up and let it go from here. It fell down, came back down here, reversed itself, came back up, and so forth and so on. So it's just a oscillating spring. These numbers that we put here, so if I take this maximum value there and I figure out what it is, that's going to be 5 centimeters. That's called the amplitude, right? The amplitude of 5 centimeters. And this other one is going the time from start to here, from one peak to the next peak. The time it takes for the system to repeat itself is 2 seconds. That's called the period. Okay. And what we'd like to do is we would like to find the spring stiffness, I believe. So we need the spring stiffness, which I didn't write there. And this is going to be a direct application of the period equation that I wrote previously, which is, oops, where's my eraser? Does that make, oh, that let me erase. Oh, how nice. Now maybe it'll let me go back to ink. All right, let's see. 2 pi over the square root of m over k. All right, so that's it. We want this guy, and we know this one, and we know that one. And we don't need to know the amplitude. So the strange thing about the simple harmonic oscillator is the frequency is independent of amplitude. If you have a non-harmonic oscillator, that's no longer true. But for a simple harmonic oscillator, it is. And we're not going to deal with an anharmonic oscillator. All right, so t here is going to be 2 seconds. 2 pi, I'm going to call 2 pi. And then the mass is going to be 200 grams. 200 grams is 0.2 kilograms. And then we need k. So the next thing we need to do here is k is under the radical. So let's just go ahead and square everything. So we have 4 seconds squared is equal to 4 pi squared times 0.2 kilograms divided by k. Those two 4's cancel. So let's see, if I multiply both sides by k, right, then I have k is equal to, let's see, pi squared times 0.2 times kilograms. I'm going to divide by the second squared as well, so we have kilograms per second squared. Okay, so that looks pretty good. So then all we have to do is sort of plug that sort of stuff into our calculator, right? We have pi squared over 5 kilograms per second squared. I like that number a lot better than this one, but you like this one better. It's 1.97 kilograms per second squared. Okay, so that's it. That's the answer, 1.97 kilograms per second squared. So where was the error I saw? There's the error. Okay, so that's basically it, right? When we did this, we just took the definition of the period, and we substituted in the values, right? 2 seconds for the period, 0.2 kilograms for the mass. There's nothing else we needed to do because the amplitude was a distractor. I guess maybe that's not what a distractor means. Then I have to square everything to get, because k is under the radical, so we need to square both sides. Anything you do to one side, you do to the other side. That's how algebra works. If I mean that basically, yeah, that's the only rule to algebra, is anything you do to one thing, you do to the other thing. That's everything else is a variation on the theme. And let's see, what do we do now? Oh, we solve for k, which is what we cared about. And so that basically meant that we canceled out those 4's, and we divided through by the second squared and multiplied through by the k, and we ended up with that 1.97 kilograms per second squared. That is more or less what you have to do with a problem of this caliber. All right, so hopefully that makes you feel a little bit better. All right, it was very nice talking to you. I will think of some fun things for you to do next week because I think there's a test. So I have to figure out how to make the test work on eCampus or whatever it is we're using. Bye now.